The world population has just broken 7 billion and is expected to reach 9 billion in the not-too-distant future. Cement and concrete are intrinsically linked to the growth and development of nations, with a direct relationship between economic growth and demand for cement. Concrete is the most widely used building material worldwide and has contributed significantly to our progress and standard of living, from our houses to our schools and universities, office blocks and shopping malls, as well as major dams and bridges. Also harbours, airports and highways that make all modes of transport possible. Cement is the most crucial ingredient for the manufacture of concrete. The cement industry falls under the non-metallic minerals segment within the South African economy, accounting for approximately 40% of the sector's revenue. And as a result of the great number of interconnected industries, any investment in the cement industry will have a significant impact on the rest of the economy. The value chain in the cement industry includes material extraction, clinker production, cement production, concrete production and construction, and end use. The cement industry is, however, a significant emitter of greenhouse gases, with cement manufacture accounting for around 5% of man-made CO2 globally. In South Africa, the cement industry accounts for approximately 1% of the national carbon dioxide emissions. It is imperative and a moral duty that everyone in the cement and concrete industry responsibly manages their ecological footprint. The cement industry has accepted this global climate challenge and is committed to a significant reduction in its carbon footprint. It is important to understand that 50% of the carbon emissions from cement production occur during calcination of limestone, which is inherent to the process. A further 40% of the emissions is due to the use of coal as fuel to fire the kilns, while the remaining 10% is made up by the use of electricity to run equipment such as the crushers, kilns and mills, as well as emissions related to transportation. In order for South Africa to achieve its Millennium Development Goals, significant amounts of concrete will be needed for the housing and infrastructure project requirements throughout the country. This will stimulate job creation in all the interlinked sectors such as transport, production, building and construction. Concrete and concrete products lend themselves to labor-intensive construction projects used in human settlements, such as roof tiles, concrete bricks or blocks, concrete curbs and paving, as well as concrete pipes, all of which are manufactured and installed using labor-intensive construction methods. The environmental benefits of concrete over the life cycle of a structure clearly outweigh the impacts from its production. When properly designed and constructed, structures made with concrete are durable, energy efficient, and last for decades with little maintenance. With a possible life cycle of more than 30 years, concrete roads offer benefits of less maintenance and lower rolling resistance, meaning less fuel consumption. In general, concrete has performance characteristics that make it suited for buildings and infrastructure projects such as thermal and acoustic insulation, light and heat reflection, durability, fire and earthquake resistance, and is 100% recyclable. Concrete construction enables sustainable high-density urban development, the key element of future sustainable cities. During its lifetime, concrete structures capture and absorb relevant amounts of CO2, which is another example of reducing the carbon footprint of concrete. There are several levers for carbon reduction in the cement and concrete industry. Quarrying or mining contributes less significantly to the cement footprint, therefore any savings would be minimal. Improved efficiency programs in clinker production can reduce the carbon footprint of cement by 10%. This is dependent on the state and age of the technology. However, if the industry was not bound by the current legal and technological constraints, the carbon reduction could be as much as 30%. Optimizing cement and concrete performance and composition and energy efficiency can translate into a 50% reduction in carbon emissions. The appropriate use of industrial products such as fly ash and slag used as extenders play an important role. We need to design and construct sustainable and climate-resilient buildings in order to reduce operational carbon emissions and ultimately provide life cycle carbon dioxide reduction benefits.
So I don't think it's a trend really, it's more a necessity that people need to go green. If we want to stay on our planet, we need to do something, and a little bit that everyone can do is to develop in a green way, but we just mustn't develop new buildings in a green, sustainable way. We also need to look at our old building stock and to redevelop the old stock in a better way, and to make sure that all our buildings are energy efficient and that we can reuse the existing buildings as well. We started with the orientation of a building. We had a look at the material used in the building. We made sure that we source all our material locally, maximum of 400 kilometers away. We try to use recycled steel for the reinforcing of a building, and the one that really stood out for us is the reuse of water in this building, especially the using of the treated effluent in the building for irrigation purposes, as well as in the cooling towers. And then we also have a small rainwater harvesting system where we can capture rainwater for flushing of our toilets and urinals. So that is really a major achievement that we had. And then on the electricity side, where we really on the lighting design, that was I'll say cutting edge. We designed for a maximum of about 400 lux at our office space areas, where the norm is a minimum of 500 lux. So with the use of very efficient light fittings and with the use of very efficient lighting tubes in the fittings themselves, we could achieve a rating and the energy saving. You know, Green Star really goes about energy saving the environment, and that is where we came in to the play with it.
The cement industry's role in sustainable building is to produce quality cement and influence appropriate use of construction materials to ensure the lowest possible life cycle ecological footprint of the built environment. As an industry, we need to develop and produce enhanced low carbon and sustainable solutions. This will only be realized by providing appropriate advice and technical support to end users. By promoting a sustainable construction industry, we can contribute to finding sustainable solutions for future generations to inherit.